Hello everyone, today I'm going to discuss with you about the questions in the diagnostic test of the AP Computer Science exam. And especially inside of this video, we will discuss about the questions with the number 21 to 27. So let's see question 21. What is the content of that? It's a very basic structure. Problem and also the method problem. So the description is as follows. Refer to the definitions of class 1 and the class 2 below. Okay, class 1 is a public class, and also it has a method which returns void called method 1. This is the first 5 lines of the class that you can show off, but it just ignored the content of this method 1. And also it tried to ignore this does not list the other methods inside of this class 1. The same thing happens in the following class, which is also a public class called class 2 and which extends class 1. The same thing happens is that except the specialized method called method 2, which only belongs to class 2, and some inheritance due to the extensions from class 2 to class 1. Other methods are not shown. So let's see the consider the following declaration in a client class. You may assume that class 1 and class 2 have default constructors. What are the default constructors of these two classes? Let class 1 C1 equals to new of class 1 and class 1 C2 equals to new class 2. Consider the following declaration in a client class. Then which of the following method will cause an error? First, the first choice is that C1 called method 2. Definitely because C1 does not have explicitly declaration of method 2. 2. C2 dot method 2. If a C2 called the method 2 will cause an error, then what we saw from the description is incorrect. But since we have already found an explicit declarations of the method 2 inside of the code of C2, so 2 will not happen, and the C2, the executions of method 2 by C2 will not cause an error. The third choice is that C2 dot method 1, which looks a little bit ambiguous, but remember that we have discussed the case that class 2 actually is an extension of class 1. So an instance of class 2 C2, it is possible let C2 to call method 1 because it's an extension, and the class 1 has defined the explicit content of method 1. So what does that mean? That means the only method call that will cause an error is the choice first. So the choice A is none, the choice B is 1 only, the choice C is 2 only, the choice D is 3 only, the choice E is 1 and 2 only. We know that obviously the answer is B. Okay, let's go to question 22. Consider the code segment. It's just a simple 4 lines of code. Do some if and else. So the first line is if n is equals to 1, we let k plus plus. Else if n is equals to 4, we do k plus equals to 4. What does that mean? That means we let k becomes k plus 4. And what does k plus plus mean? That means we let k becomes k plus 1. So inside of this 4 lines of code, separated by the if and the else if cases, it handles the conditions when n happens to be of value 1 and when n happens to be of value 4. Okay, now let's continue reading the description of question 22. Suppose that the given segment is rewritten in the form, that is, if some condition, then we do the assignment statement that given that n and k are integers and that the rewritten code performs the same task as the original code, which of the following could be used as? One, the blocks inside of the if conditional statement, and the block 2, the blocks of the assignment statements within the condition of 1. So it's just like that. We try to merge 4 lines of code to 2 lines of code. And since we have already recognized from our previous discussion that either when n is equals to 1, we let k equals to k plus 1, and when n is equals to 4, we let k equals to k plus 4. So that means we only have to focus on the cases when either n is equals to 1 or n is equals to 4. So let's see what kind of choices that we can find from A, B, C, D, E. From A and B, we know that we don't have to consider, because from A and B, they consider the case is n is equals to 1 and n is equals to 4. It is almost impossible. If n is a integer value, it could not be equals to 1 and equals to 4 at the same time. So if there are some if condition like this, first we know that logically it does not make sense. Second, that because we have already checked the case, is we want to merge 2 different cases, like either n is equals to 1 or n equals to 4. So we cannot just merge them with the cases of the interpretation that n is equals to both of them. Actually, it should be or separated by that instead of and symbols. So we consider the choices C, D, and E. Now, what's the rest part? That is the second blocks of the sign statement. We know that k will be equals to, when n is equals to 1, k will be equals to k plus 1, and n is equals to 4, k will be equals to k plus 4. So that means it just depends on the value of n. So choice C, it assumes that k will be equals to k plus 4, which is apparently false. And also choice E, it assumes that k equals to m minus k. That is also very weird. So the choice D is correct, because when n is equals to 1, then k is equals to k plus n, which is equals to k plus 1. And when n is equals to 4, k is equals to k plus n, which is equals to n plus 4, which happens to be the case that we have read from those 4 lines of code in the description of this question. Now let's see question 23. The question 23 is described as follows. Which of the following will execute without throwing an exception? So there are only 3 blocks of code. The first block of code is trying to assume that string s is equals to null, there's nothing, and also string t is equals to the empty string. Then we do the comparison to compare if the string s is equals to string t. If the string s is equals to string t, then it print out the results of the string, that is, this is an empty strings. The second block is we assume that string s is equals to the string holy, and the string t, we assume that it's equals to the string moly, and we compare if either holy is equals to moly. If holy is equals to moly, then we print out that holy moly. Okay, the third block of the question is we assume s is equals to holy, and we assume that t is equals to the substring, starting from the next to the index of 4 of the string s. Then we print out the results of s plus t. Let's see, among all these 3 blocks of codes, what will execute without throwing an exception? We know that the first one might have some problem because s is assumed to be null, which means that although we declare that s is of type string because it contains no initialization of the content, So we cannot do something like callings of equals because the instance of S has not been assigned of any specific memory location. So one, at least for the first cases, some error were executed, were thrown out from the execution. The second one, although it looks a little bit logically silly, but since they are well-defined content S and T, so we can compare wholly with moly without any question. Okay, the third choice is we might have doubt that because the definitions of a string T is trying to execute the substring of the index 4 of S, but however, we know that string S equals to wholly, which has length 3, which means that its index should only between the range of 0, 1, 2 until 3. So is it possible that we can access the substring of index 4 of S? Actually, I think this is depends on the compilation techniques. If we pass by some index which is out of the range of that, the substring method will just return some empty string. So we can still do the following thing by printing the concatenation of the string S plus T because the string T is just empty string. So the results will be in the third blocks of code will only print out with wholly. So what is the question? Which of the following were executed without throwing an exception? It's not okay with throwing an exception. We know that the first one will throw some exception because of the non-declarations of memory, but the choice 2 and 3 were executed very well. So the choice of this question should be E, 2 and 3 only. Let's see question 24. There are three numbers A, B, and C are said to be a Pythagorean triple if and only if the sum of the squares of two of the numbers equals the square of the third. And excuse me, a programmer writes a method is a Pyth triple to test if it's three parameters from a Pythagorean triple. So before the method, there are some comments says returns true if A times A plus B times B equals to C pi C, and otherwise returns false. So that is, we use the public static boolean of the method is Pyth triple of the input with three input parameters of type double. That is type double A, double B, and double C. And the content of those two lines of code of the method is double D equals to the math dot square of A times A plus B times B, and then we return either D happens to be equals to C or not. So it returns true or false because it has declared that the return value is of type true or false. Now, when the method was tested with the non-Pythagorean triples, is Pyth triple sometimes erroneously returned false. And what was the most likely cause of this error? Let's see the 5 different choices. The choice A is route of error was caused by calculations with the floating point numbers. This is possible because A squared, okay, if A is a floating number, and if we do some A times A, the accuracy of A times A and the accuracy of B times B might have some problem. And also, after we taking the square root of the results of A times A and B times B, we might need some specialized. For example, if we A times A plus B times B equals to 2, then we might only access like fixed numbers of digits after we taking the square method, which means that if a D has more digits or has some rounded versions after the square root, then the comparison between D and C will not be that accurate, so that's so-called round-off error. Okay, let's see choice B. Type boolean was not recognized by an absolute version of Java. We don't consider such kind of things. We know that at least from an old versions of Java, this is just a very basic fundamental type of data, like integer, double, floating point, boolean, all of those should be recognized by all versions of Java. Okay, what's the choice C? An overflow error was caused by entering numbers that were too large. If the entering number is too large, then it's not overflow error. I think it's just some errors for checking the type. Choice D says that C and D should have been casted to integers before testing for equality. If that is true, then there's no error, right? If C and D are exactly the same value, and it has been casted to integers with the same method, then there will be no error. But we are considering the conditions where this method sometimes returns error, so we don't consider choice D. Okay, the choice is that bad test data were selected. Yes, we don't try to examine the best. Okay, so the bad test data, whether the data is bad or not. But since we'll consider what is here, when the method was tested with a non-triples, sometimes erroneously returns false. So if the bad test data were selected, then it should always return false. But if it's just like for the case of sometimes, then we should not select E. Okay. Okay, let's see question 25. Refer to the following class containing the mystery method. Now, what is this mystery method? The class is called SumClass, and it has a private integer array called ARR. And let's see, there are some constructors. Initialize the ARR to this array, private array, to contain a non-negative integers k, such that k is between 0 and 9. And what else? Okay. Public SumClass is the constructor, and in this description of the code, we just ignore that part. It has some comments saying that it is implementation, not shown. How about the rest method of mystery? Okay, is okay. Integer value equals to AR 0. That is, we're trying to access the first element, first integer of the array. Then we scan through all the index, starting with index I equals to 1 to index I, which is less than AR.length, which means that it will scan till the end of the element, because the last element of this array should be AR of index AR.length minus 1. So I will stop at that value of within this for loop. Now, what's inside of this for loop? We let value equals to value times 10 and plus AR of I. Then finally we return value. That means at the beginning we might let value equals to AR 0, but then when I equals to 1, then AR 0 will times 10 and the AR 1 will be attached to later on. So what does that mean? For example, if AR 0 is equals to 5, then and AR 1 is equal to 9, then what will happen is AR 0 at the beginning it will be equal to 5, the value will be 5. Then after the for loop, when I equals to 1, then the value will be 5 times 10 plus AR 1 equals to 9, then which means 5, 9. So that means we're only trying to shift the value of the original old index, then try to attach the new index. Because we assume that the initialized ARR to contain non-negative integers k, such that k is between 0 and 9, so actually we can only treat up these blocks of code as just some shifting of the value of digital numbers. Okay, so let's see the 5 different choices of this question. Which best describes what the mystery method does? A. It sums the elements of ARR. No, we don't do the summation. We know that it's just a shifting. So B. It sums the product 10 times ARR0 plus 10 times ARR1 plus blah 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 plus 10 times ARR of ARR dot length minus 1, which happens also not to be true because is shifted all the time. So AR0 should be shifted not only by shifting once, because when we say 10 times some index, which means that we just shift it to the left hand side for 1 bit. So we don't consider the choice B, which is definitely incorrect. And let's see what's the content of choice C. It builds an integer of the form d1, d2, d3 until dn, where d1 is equals to ARR0, d2 is equals to the ARR1, and so on until dn is equals to ARR of ARR dot length minus 1. And if you read the description carefully, we know that the choice D is just the reverse, because in this case, in choice D, we assume the description is that D1 is equals to AR of AR dot length minus 1, D2 is equals to AR of AR dot length minus 2, and so on. And the last item of the choice D is that Dn is equals to AR0. So it's a reverse of the string. But obviously, we know that choice D is what we just saw when we try to analyze the code of this for loop. So C should best describe the mystery method does. And it's not a mystery anymore. Choice E, it converts the elements of AR to base 10. That means if it converts elements of AR to base 10, actually it's a little bit ambiguous because AR is an array, and if since its digital value is always between 0 and 9, so we can claim that if we treat all those elements separately, we don't have to do some conversion. But if you trying to gathering the content into just one number, we can say this is a conversion. So C should be the best choice of this question. Let's see. This is a group of code that we will try to use as answering question 26 and 27, because questions 26 and 27 refers to the search method in the searcher class below. Okay, this is a public class called searcher, and inside of this public class of searcher, there is a private integer class called ARR, and following that, there is a constructor initialize the ARR. There's a private array of integer type. And the implementation code, unfortunately, is not shown here. But later on, there's also another method called search belong to this searcher with the following precondition. AR first until AR last is sorted in ascending order. And what's the post condition? It returns index of key in AR. If a key not in AR, it returns -1. Okay, let's see what is the content. Public integer search of 3 parameters: integer first, integer last, and an integer key. Actually, if you read the code carefully, actually it's binary search. It beginning with integer mid, which happens to assume that it's the index of the middle number of this array. And we do is that while first, which is less than equals to last. Then we let mid equals to first plus last divided by 2. And if ARR of mid happens to equals to key, then we return mid, because mid is definitely the specific index inside of this private array, integer array called ARR, which has the exact value of key that that we just saw as the third parameter of this search method. Else we do the following thing. If AR of mid, the values that we located from the mid index inside of this array is less than key, that means we have to consider the key to right of array of mid, because all the elements which is less than array of mid we should not try to locate it at. We assume that it's sorted in a ascending order by the preconditions of this code. So we let F first because it becomes assigned with the value of a mid plus 1. Otherwise, which means that the right hand side, the right half part of the array should not be considered, because that means AR of mid is greater than or equals to key. So that means we should let the index last, because becomes the assigned with the value of a mid minus 1. That is, we only have to consider the left part of the subarray. Okay. If everything has been done but still cannot locate the content after we finished the while loop, that is when first and last they are so close, and also maybe mid is overlapping with first, or mid is overlapping with last, but still cannot find it, then we break out from the while loop and returns minus 1. So this is a very classical implementation of binary search of this search class. Let's see question 26. Which assertion is true just before each execution of the while loop? A. ARR of first is less than key less than ARR of last. We don't know, because the while loop might break out. So actually, keep in mind is the key should not always between ARR first and ARR last. So A and B we should not consider, because there are several cases that they have never considered. Instead of that, we should consider choice C and D. Why? Because key might not actually inside of the whole array. So key is not in ARR should be the default cases. Okay, what's the difference between a choice C and D? That choice C, where key should be greater than ARR of first and less than ARR of last. And D is ARR of first, he should be greater than or equals to ARR of first and less than equals to the ARR of last. So it just depends. If there are some repetition elements instead of the array, then we should consider that D is true. But if there is only distinct elements by our preconditions of the array, then choice C should be the answer. Let's see choice E, that key is less than equals to ARR of first, or key is greater than equals to ARR of last, or key is not in ARR. At least the first two cases we don't have to consider. Because if that's true, then that means the while loop will just break up. Okay. So the correct choices of this question should be D. Let's see question 27. Consider the array A with values as shown: 407, 19, 25, 20, 36, 20, 37, 50, 100, 100, 101, 205, 220, 271, 306, 321, and where 4 is a 0 and the 321 is a 13. Suppose that the search method is called with first equals to 0 and last equals to 13, which means that it's the first element and also the last element has been covered by the indexing. And to locate the key to 05, How many iterations of the while loop must be made in order to locate it? Okay, let's see. Yeah, actually, just trying us to think like a Java compiler, the execution environment of Java. Okay, how many iterations? Okay, the first iteration is that a0 equals to 4, a13 equals to 3 to 1. Then what's the middle? Middle is a6. And what's a6? A6 is equals to 50. So this is the first time. Then since we know that 205, the key value, is greater than 50, then the second time we will start with A7. That is, A7 is equals to 100. This is the first. And the last is A13 equals to 3 to 1. The middle should be 7 plus 13 divided by 2. That would be 10. So that means the a middle will be 220, right? So this is the results of the second time. Since 220 is greater than the key value 205, so we need to do for the third time. That is, we trying to let the last becomes 9, and let the first still keep as 7. So that means middle will become 8. So this time it will retrieve the element 101 comparing to 205. Then we know that 101 should be less than 205. So we do the fourth time of comparison, and finally we will locate it the exact locations, which is of value 205. That is A9. So that means it needs 4 times of execution in order to locate it. So the choice should be B. Okay, thanks for listening to this brief discussion about how to solve the questions between the diagnostic test 21 to 27 of the test. Question 21 to 27. And if you're interested in to join us, please go to our website and consider the cases and also the class time. And hopefully we will see you soon. Bye.